students, and welcome back to Engineering Mechanics. Today we are going to be dealing with the topic Kinematics of a Particle. Before we begin, let us just review engineering mechanics a little. I had told you all engineering mechanics is broadly divided into statics and dynamics. What is statics? Statics can be defined when a body is completely at rest, okay, or if it is traveling with uniform velocity. That means the velocity is constant and the acceleration is zero. Yes. Now what is dynamics? Dynamics means that the body is always in motion. Okay. But dynamics can again be divided into two parts. One is kinematics and the other is kinetics. What is kinematics? Sometimes a body, whenever we see live examples, in live examples we see a combination of kinetics and kinematics. But how can we distinguish between both? Kinematics deals with the geometry of motion. Say for example, you are having a particular object which is moving. Then the velocity, the acceleration and the position of the object is changing at different instants of time. So you are having a position, you are having the velocity and you are having the acceleration at various times. Okay, so that is basically kinematics. Now when you are dealing with kinetics, we are usually focusing on the second law of Newton, that is summation of forces is equal to mass into the acceleration. Now if you see a live example, let's say that a truck is being towed. Okay, so there's a truck which is being towed with say 30 kilonewton force and the weight of the truck is say 3 tons. From this we can easily calculate the acceleration with which the truck is moving. So the truck moves with 10 meters per second square acceleration. But in this case, the truck has been changing its velocity and has been changing its position at different instances. Yet from this particular equation we do not get that. Whereas from this equation we are able to calculate the acceleration easily. Let's consider a second example. Say for example there's a car that is moving on a curve. Now if there is a car that is moving on a curve, say we have given all the different positions, we are given the velocities, we are given the different accelerations of this car at different instances. But while we are moving in the car, we are ourselves also experiencing some force in the outer direction. Okay, this force will come into equation when you take Newton's second law. So both these equations are interrelated with each other. Let us see a few basic quantities that we have to refer before we carry on with this particular topic. Okay, now the first concept is distance. What is distance? I came upon a very good example. Say for example a bee wants to go to its hive. Okay, so you've got a beehive over here and you want a bee to go to its hive, but the bee directly just doesn't go to its hive. Okay, it roams and then goes to his hive. So distance is basically the entire path traveled by this particular bee till it reaches its hive. But what is displacement? Displacement is simply the shortest distance between the initial point and the final point. Therefore, this becomes the displacement. Now, the distance is always the entire length and therefore it is a scalar quantity. Whereas, and it is independent of the path traveled. Okay, it is independent of the time taken, but the displacement, in displacement you've got a direction. Now this particular direction is straight, so it has a particular angle. So displacement is the shortest distance between the initial point and the final point, and it has a definite direction and therefore it is a vector quantity. Okay, now let's go with speed. What is speed? Basically we always denote speed as distance upon the time. Now distance means the complete path traveled and the time taken. This is speed. But what is the velocity? Velocity on the other hand is the displacement divided by the time. Now let's carry on ahead. Here again we know that since displacement is a vector quantity, the velocity itself also becomes a vector quantity, whereas speed is a scalar quantity. Okay, now what is instantaneous velocity? We have traveled on our bikes, on our cars. So whenever we see the speedometer, we are able to calculate at that particular instant how much is the velocity. That is known as the instantaneous velocity. It does not depend that maybe 5 minutes ago I was with some other velocity, or maybe 2 seconds later I'll be with a different velocity. Instantaneous velocity simply means that at that particular instant, what is the velocity with which you are traveling. Okay, now we've got what is average velocity. Average velocity is basically depending on, it is directly proportional to the displacement and is inversely proportional to the time. Say for example, there is an object which moves, say with 150 meters, whereas there's an object y which moves only 60 meters. Both move in 30 seconds. Okay, automatically you know that there is a change in average velocity. Let's take another example. Say there is a particle that is A which takes about 20 seconds to travel a distance, whereas particle B takes about 25 seconds to travel the same distance. The distance was say 40 meters. Okay, again the average velocity with which particle A is traveling and with which particle B is traveling are both different. So this is what we are going to be calculating. The average velocity in each case will be different.